Hi, Alok. Good afternoon. Good afternoon, all the participants.
Welcome, sir.
Uh,
Just 1 minute. Good afternoon, sir.
Good afternoon, Alok.
Welcome, sir. So we'll start soon, sir.
Yeah,
So are you ready, sir?
yeah. I'm ready.
Okay. So, dear participants, few people are joining. So let them join one by one. So we are now going to start our third day schedule. That is our session fifth on machine learning using Python programming. So uh, our sir Aswini Kumar Patra sir will cover this topic, machine learning using Python. So before starting the session, let me introduce sir to you. Aswini Kumar Patra sir received his BTech degree in computer science and engineering from NERIST, Arunachal Pradesh, and MTech degree in just 1 minute, sir. MTech degree in computer science and engineering from IIT Kharagpur. He has been a faculty member with the Department of Computer Science and Engineering, NERIST, since 2006. He is pursuing PhD in neuroimaging and multimodal algorithms at IIT Guwahati. His research interests include machine learning, evolutionary algorithm, medical imaging, and computational biology. Sir, I request you to uh, start your session. The
Yeah,
platform is yours, sir.
yeah. Thank you, Alok.
Thank you.
Good afternoon once again, all the participants. So today we'll be now in this session. We'll be discussing about machine learning using Python. So I have planned the talk just to address the basics. Assuming that you all are learning Python. So based on the basics, I have prepared something, and because the Python and machine learning is a very vast subject, so we could not cover that in 1.5 an hour. So I plan to talk about a bit of machine learning using classifiers in Python. Okay, so let me share my screen. Am I audible?
Yes, sir.
Yes. So to start with, I would like to mention that Python could be used. The Python platforms I need to mention because many times I have been coming across this question that what will be the effective way to write the programs. So I prefer this one, Spider IDE, but most of the people prefer this one, Anaconda Spider. But I have seen that the Anaconda is very, very slow because it needs so much computational resource. The hardware resources and operating system utilities, it captures so much, so it is very slow. So I would not prefer that. But Spider ID is very much comfortable. And these days you have internet available, then you can use also Colab. It's a facility provided by Google. And the benefit is that you could carry out many kind of intensive computing so that even if you have a very low configured system, still you can go to Colab and you can have some kind of big data analytics using machine learning. Okay? These are the three platforms. So now we'll be talking about our codes in Colab. Okay. Now talking about Python packages in machine learning. Okay. But before that, let me talk about a few things about machine learning. Okay. So machine learning is something where you can generalize the things without any memorization. Okay. For example, you have been told that I mean 10 days temperature, temperature of 10 days or 30 days, and now you are asked to predict the temperature of 31st day. So if you memorize all the temperatures and just to tell that 31st day will be this temperature, this will be a very wrong approach. Okay. For example, in earlier days, there was machine learning kind of stuff that the people call that technique as AI. Let me talk about those days thing that is called expert systems. In expert systems, what was the thing that if somebody was having the symptom 1 and symptom 2 and symptom 3, then he must be suffering from fever or TB. Else, if S1 and symptom 7 and symptom 9, then he must be suffering from, let's say, cancer, and so on. And you could not believe, gone were those days where such algorithm could be called as artificial intelligence. But believe me, people initial days call this kind of stuff as artificial intelligence application, where things are memorized. This is nothing but memorized. Okay? The system doesn't generalize, it's memorized. But now these days, what we do is generalizing the stuff by doing that. If X is something and Y is something, then what we do is, if the values are like 4, 5, 6, 7, and it's 0.2, it's 0.4, it's 0.6, it may be 0.8, then we plot a graph. So next time, whenever X is 9, we could easily guess what with my Y. So it's a kind of curve fitting. So the idea is I'm just finding the slope of this curve after plotting my XY data. Okay. And here, I could guess if new point comes into picture like X equal to 9, then I can guess what should be my Y because I know slope of this curve. So this is a kind of generalization example. Okay. And throughout, all these 2 decades, the machine learning has been a buzzword, and people are using many models to carry out the machine learning task. And primarily, machine learning involves 4 kind of stuff actually. One, they call it classifier, which is a supervised learning. The other is clustering, which is unsupervised learning. Other than that, there is also a technique called dimension reduction. Dimension reduction is something where the features of the data set is so high so that I cannot carry out any kind of analytics. So to make my analytics very effective, what you do is reduce the dimension. Okay. And the fourth is outlier detection. For example, you have thousands of mangoes, but within that mango, if there are 2 or 3 apples there, then of course you call these apples as outliers. Okay. So these kind of applications are there as part of machine learning. Now, as far as the today's class is concerned, today's discussion is concerned, I have been told to do something practical because the objective of this workshop is to carry out some practice stuff. Okay. So here I would like to mention that there are many packages for machine learning, and every package comes up with relative merits and some weaknesses. Okay. And I would mention them, and if you're really interested, you can also explore much of them. Okay. Scikit-learn is one. PyTorch, Keras, these are 3 packages, and Keras is particularly for deep learning. And this TensorFlow, Theano also used for deep learning processing, and NumPy and Panda is for data pre-processing and data processing, we can say. Because the machine learning is nothing but having so much observations in the form of data, and those data are going to be processed, then only we can give in the appropriate format to the algorithms. Okay. So these are the packages. Now, after knowing the packages, I'd like to inform you that there is something called package module structure in Python. Okay. So there is a difference between package and module. Yeah. So the idea is this is the main package, which we call it a game. Maybe game is a package example, and we have many sub packages, known as modules: sound module, image module, and label module. And each module has many functions. Okay, sound has these functions written in the Python. So the extension is .py, and image also, and for the label. So what I mean is that we are going to use many kind of modules and packages in a directory structure. So you should not confuse. So in a Python program, why the Python is popular? Because there are so many inbuilt functionalities. Okay, in the name of in the form of library packages, we call it. So in C, you do not have much library packages. We have only some kind of system functions. But in Python, just because it is open source, many people have written many packages, and that is publicly available. And you can just simply import those. Import is a keyword. Import these packages, and now these packages are going to be used down the line in my program. So if this is the structure, we can say import game. In that case, all the sub packages also be imported to my program, and I can make use of it. Or I can also, if I want to only access this load, so how could I write? I can write like import game.sound.load, because game includes sound and sound includes load. Okay, this is the structure. Or alternatively, you can write also like this: from is a keyword. Okay, game.sound import load. I mean, if I want to make use of load, I can import load from game and sound directory. Okay. I hope this is clear to all of you. Any doubt? So just to make sure that the participants are listening, I have to sometime ask some acknowledgement. Someone has to tell yes or no. Whether am I audible? Participants, please.
Yes,
Yes,
sir.
sir. Audible.
Yeah. You are
Yeah.
audible, but volume is very less actually.
Oh, volume is less.
Yeah, I don't know why. Yesterday it was fine. The day before yesterday also it was fine. I don't know.
Okay.
Maybe from my side. I don't know.
Okay. Let me cross check by someone else.
Sir, it is audible in my computer.
Okay, sound is fine. Huh? Let me check one more.
Okay.
Chiranjit
No issue.
Biswas, please. Chiranjit Biswas, or anybody for that matter. Am I audible clearly? Okay.
Yes, sir.
Okay. Thank you so much. Let's continue. So with this thing at hand, we'll proceed for talking about the machine learning programs in Python. Okay. So as I told you that we'll be talking about classifier first. Okay. So in classifier, what is happening that we have many things which we call expected or a target value. These are synonym. Okay. We have suppose 2 cats, 3 dogs. So we have these things, and what my algorithm predicts is this is dog, this is dog, this is cat, this is cat, and this is cat. So what is my accuracy? Can anybody tell? Suppose I gave so many features to the, to the computer, to the algorithm, and I have these cat, 2 cats, 3 dogs, and my model predicts dog, dog, cat, cat, cat. So the accuracy is 0, Why the accuracy is 0? Because while I am expecting a cat, my model predicts dog. While I'm expecting a cat, my model predicts dog. And when dog is predicted, when I should get dog, I'm getting cat, same and same. So in all my 5 cases, I failed. So the accuracy is 0. So this concept could be capitalized, I mean, could be represented by a matrix called confusion matrix. Okay. So these are my actual values. These are my predicted values. Okay. Let's talk about 3 classes. And I have also in program, I have written this. So this simple program will be the starting point for today's program. Okay. So I've written some programs. Instantly writing the programs will take so much time. So I'll explain the programs line by line. And now I'll be using Colab, as I told you. Escalon is the package from where I imported the metrics, because metrics involves the assessment procedures for the efficiency or to calculate the accuracy of my model. Okay, just like the packages modules I told you in some time before. Here in my page 2. Okay, from game.sound import load, that similar way I imported metrics from Escalon. Okay, Escalon is a machine learning package and it is known as scikit-learn. Now I want to have 3 classes. Cat, fish, and hen. For your clarity, I have defined them. C is for cat, F for fish, H for hen. Now, my true values are known as expected. I mean, this is my target or expected. As I told you that my actual output should be like this. But due to the model, I'm not writing the model here. One by one we'll learn. I'm just starting with the matrix. That's a matrix is not a matrix. It's a matrix. This means the assessment procedures to assess the efficiency or accuracy of the model. Now these are my predicted values. Okay. Now I want to calculate the accuracy. So how to do that? We have to print the confusion matrix. So for the confusion matrix, I'm writing matrix dot confusion matrix. That means this matrix module includes other files like confusion matrix. So matrix is a keyword, confusion matrix is a keyword. You should not be confused. So what is a keyword? Keyword is something whose meaning is fixed. Okay. So I would repeat that expected is a array. Why predict is a array? I mean, I'm predicting something. Expected is my target values, my actual values. That means now I want to print my confusion matrix. Let's run it. I just click this button on Colab. It means executing the program. My network is a bit slow, it seems like. So you see, I got a confusion matrix. Let me increase my font size. Is it a bit more? Size is a bit more, of course. Now, see, this is a confusion matrix. So what do you interpret from this confusion matrix? The diagonal element says that I'm expecting cat and I got 4 instances where my cat is true. I'm expecting fish and in 2 instances fish is true. My third is hen. During my hen, I'm expecting only 6 hens. I mean, I'm getting only 6 hens. So what is the total? The total is something, but the accuracy is 4 plus 2 plus 6. If you are not clear about the stuff, I will tell you that this is my cat, this is my fish, this is my hen, actually, and I'm predicting fish and hen. 4 times I'm expecting cat and I'm getting cat. Twice I'm getting fish, sorry, actually it's fish and I'm also getting fish. And there are 6 instances, the actual value is hen, I'm getting hen. So the total is 4 plus 2 plus 6. And what are these values? These are the values which really contribute towards my inability of my model. Okay, inability of my model, because more the values, lesser will be my accuracy. Okay, so the total value is, I mean, the total number of inputs. This is my accuracy. Okay, so let me print my other stuff as well. But if I say what is my accuracy score, we have to print the accuracy score. See, accuracy is 0.48. Okay, and after that also I would like to show you so many things here, that they are also part of my metrics. I can print my classification report. See, look at the classification report. And 0.48 is my accuracy. As you see, accuracy, you look at the accuracy, and 0.48 is the accuracy, and 25 is total inputs. And out of 25, I have 12 is the accurate prediction. 12 by 25 is 0.48. Okay, so other than accuracy, we have also other measures called precision, recall, and F1 score. Okay, what are they in fact? I'll tell you. And before that, for cat, precision is 0.31. For fish, precision is 0.67. For hen, precision is 0.67. Similarly, for recall, for 3 classes are these. F1 score for the 3 classes are this. But the final assessment is what is the accuracy. But other than accuracy, we have to have this precision and recall also as important part of our discussion. Why? Why so? Why so? Because suppose we have a model to test out corona. Okay, so in corona it will check either positive or negative. Get my point? So whenever I'm expecting positive, I'm getting positive, it's fine. Model is working fine. Whenever I'm expecting negative and getting negative, model is working fine. But whenever I'm expecting positive, I'm getting negative. Get my point? This is not at all fine. But if someone is negative but getting positive, still it's fine. I mean, it's very serious issue, not fine in both the cases, but it is not that serious. Not serious in corona perspective, because if someone is positive and falsely, if it has been declared as negative, and that guy will be roaming around and spreading the disease. Get my point? But if someone is negative but he's been declared positive, that person himself will be suffering because he has to go undergo quarantine period, but it is not affecting the population. Get a point? So from this conclusion, the idea is that even if in a binary classification model, the confusion matrix looks like this, and out of my 100 inputs, this is positive, this is negative maybe, this is positive, this is negative maybe. Out of this 100, it is 40, it is 45, so my accuracy is 95%. Okay, and suppose I'm expecting positive, I'm getting negative 3, and I'm negative getting positive, but 3, that 3 is very, very dangerous. Okay, that 3 is very, very dangerous, and that could be addressed by this kind of parameters. Okay, sometimes accuracy doesn't matter, and that sometimes nothing but the classical example is corona, where this small value is making my model very, very inefficient, because I must not have this kind of result, because this 3 also could infect 3 lakh people in my population. Okay, so depending upon the application specific thing, we are taking into consideration the appropriate metrics. Okay, these are my metrics. What is my appropriate metrics? The application at hand would decide. Okay, and how we get this? It's in front of you in this program. Any doubt so far? It's a very small program. We have not written any model in machine learning or in Python, but what we learned is how to make use of package, which is nothing but sklearn. From sklearn, we derive the module metrics, and by making use of this matrix, I calculated the result like accuracy score and the whole classification report. Okay, so this classification report is also a keyword. So for this, you can go to the documentation part of scikit-learn and get to know about these keywords. You have to have the tutorials at hand or the documentation manual with hand. Then only you can get to know which are keywords and which are not. Okay. Any doubts so far? Am I clear? Anybody please acknowledge?
Yes, sir.
Yes. Now next program. The next program is that we will talk about a classifier. So I can click on this plus code button, one new platform comes up, one new window, and here I can put my statements, which are nothing but includes packages and the corresponding modules in my program. So MLP classifier is the multi-layer feed-forward network. Okay, that is also known as backpropagation algorithm. So in this course, in this discussion, we are not talking about the algorithms, but the implementations. Okay, so I'm not going in deep of what is MLP classifier is all about, but MLP classifier is based on backpropagation multi-layer feed-forward network. It's a very famous neural network algorithm. Okay, but by using that algorithm, now we are going to calculate the accuracy and classification report of some data. Let's have some data, very simple data. So this data is some kind of binary logic. Whenever 0 and 0 are the input, I'm getting the target 0. Whenever 0, 1 the target, I'm getting 1. And 1, 0 is my target, getting 1. And 1, 1 is my target, getting 0. So giving these two things, now I want to check my model using MLP classifier. So let me execute that MLP classifier. How could I write that? I can write my model is not a keyword, remember, okay? But MLP classifier is a keyword which has been imported from scikit neural network package. And there are many parameters. If I do not use any parameter, I can skip it, okay? And I'll also show you something. Let's say MLP classifier scikit-learn. Let's go to the definition. You see, look at here. MLP classifier has been taken from the class sklearn.neural network. Okay, I I defined that. Then dot MLP classifier, and in that MLP classifier there are so many parameters. Okay, because neural network needs so many parameters like number of hidden layers, activation function. I mean, the variety of activation function is ReLU, and there is also a solver called Adam. Okay, I mean the stochastic methods that we use. There is a parameter called alpha, batch size, learning rate, and initial running rate, and so many parameters. Okay, if you look at the model, you get to know. And there are many parameters which are by default there. Get my point? For example, it says like the ith element represents the number of neurons in the hidden layer, and by default it is 100. Unless otherwise mentioned, it's 100. And unless otherwise mentioned, the activation is ReLU. Otherwise, there are many activation functions like identity activation function, logistic activation function, hyperbolic 10 hyperbolic function, ReLU, and so on. So ReLU is by default there, and so on. Okay, so in my program, if I do not mention any parameter, so default parameter has been taken. Okay, now I want to print the accuracy of my model. Let's run. See, the result I'm getting is 1. That means the accuracy is 100%. Okay, so the accuracy is could be represented from 0 to 1. 0 means 0%, 1 means 100%. If it could be 0.8, you could have assumed that the model is delivering 80% of the accuracy. Okay, so this is my accuracy report, and if I want to print the whole classification report, then I have to print my different statement mean for this. There is some error. Okay, okay, prediction is something I have not taken care of. The confusion matrix, can you see the confusion matrix? 2, 0 and 0, 2. The diagonal elements are 2 and 2. And the total number of data in my input data is 4. So 4 by 4 is 1, which gives me 100% accuracy. So you look at this prediction, it really predicts the things, because confusion matrix function needs 2 parameters. One target, the other is prediction. And the target we have decided in the very beginning, and my model must predict. Okay, so the prediction, I mean the training. See, look at this MLP classifier. This is called training. Okay, after training this data, I'm giving my data to the variable called my model. So my model is not a simple variable, but a data structure, and it contains all the information generated from my MLP classifier training module. Okay, then I can calculate accuracy by using that model and using the keyword score, which takes the input data and target. Okay, and we printed the accuracy. Or we can use another keyword called predict, which takes the data itself and gives the prediction. Get my point? This is how we do. Any doubts so far? And I will show you something in this stuff like see, predict is a function, predict using the multi-layer persistent classifier. Fit is a function to fit the model. Okay. And score is a function which takes two input that return the mean accuracy on the given test data and labels. Okay. And in this case, my test data and training data size is same. Yeah. See, fit and predict models, I will show you. This fit is a function here, whose definition is here, and predict is a function here, score is a function here, and these things we used here. You see, fit I used here along with MLP classifier. Okay, the model is fit. Now the score is used to calculate the accuracy, and I'm also using prediction to get my predicted values to print the whole confusion matrix. Clear? Or if possible, I can print my classification report as well, you see. Something. Okay. Let's not misuse the variables. Here the variable is prediction, and expected is something which is called target in this program. So we must be aware of these variables, okay? Because target is my expected value and predicted values are here. So this predicted value and this target value can generate my classification report. So this is my classification report. At the point. So for both the classes, my precision, recall, and F1 is 1, 1, 1, and so on. Now, coming back to some other problem, I would like to talk about a decision tree classifier. Okay. And let me take a 5-second break to have some water. I have a question that whether you could follow me or it's just like very difficult to follow. Please acknowledge.
Participant, please response.
Yes, sir, we are following you.
Okay. So let's talk about another program. Here I want to have data sets. Okay. So data sets means there are many inbuilt data sets there for analysis point of view. If you have a very new data set, you can take from the secondary memory as well. Okay. Secondary memory means from your hard disk also you can take. And I'll show you the both procedure. So data set is imported from Escalon, matrix is imported, and I'm going to use another classifier instead of MLP. I'm using decision tree classifier, and you must be knowing that there are many popular decision trees which are called tree induction in machine learning, and very, very popular methods. Okay, and the extension of this decision tree is known as random forest, where we employ a series of trees and their outcomes to infer something or to predict something or to classify something. Okay, I think these three lines are clear very much. Now I want to load the data set. So this data set is there inbuilt in my Python package. So that is iris. Okay, and let me show you iris package. So iris package has three classes called iris setosa. It's kind of some flower, and there are three flower types: iris versicolor and iris virginica. Okay. These are three species of rose, I think, if I'm not wrong. And it has four attributes: sepal length, sepal width, petal width, length, and petal width. Okay. Based on these four values, we have this label. So remember that we are talking about the classification problem. So we have labels there, just like targets. So the F column is my target, and B, C, D, E column are my data. Okay. If these features are there, it will be iris setosa, or and vice versa. If these features are there in my 51 line, it will be called iris versicolor, and so on. Now let's fit a model. Decision tree classifier is the model. I want to fit it. I mean training it. And to train, you see, this is data set though. Dataset.data is a format, and dataset.target is format. This data and target are fixed. Okay, then only I can have the data and target. Get a point? So this data set is nothing but the dimension of this data set is 150 by 4. That means 154 row and 4 column. Okay, and this target is 150 row and 1 column. The 1 column is meant for my labels. Labels means, as I show you, iris setosa or iris versicolor, and so on. Now, after fitting this, I can print my accuracy report and so on. My expected, which is nothing but my data set target, that is 150. I can write like its size is 150 by 1. Okay, 150 row and 150 column. Now, I use my predict function. See, model predict, because by this statement, can somebody acknowledge whenever I highlight the line, is it visible to you at your end?
Yes, sir.
Highlighted line is visible. I have highlighted fit function.
Yes, sir.
Yes, very nice. So by this line which has been highlighted, it's the training part. Okay, after training part, I want to predict by this line. Okay, now I have two data structure, or we can say two column vectors, having my, by putting hash, I'm making it non-executable just for comment purposes. So I have my expected result with me, I have my predicted result with me. Now we can generate the classification report and accuracy score. How to do that? We have already discussed twice. See, classification report is the keyword, as I told you. Expected and predicted are two inputs. And I also try to print my confusion matrix. See, I got the result. Look at the result. The classification report gives me precision, recall, and F1 score of each of my classes. There are 3 classes as you saw, and every support means every class is 50 data or 50 rows. The total is 150, and the accuracy is 1. That means 100% accuracy we are getting by using a decision tree classifier for iris data. Clear? Any doubts so far?
No, sir.
No. Now I'll show you how to read the data in Colab from your hard disk. I mean, any kind of Excel file or CSV file that also could be read. And I want to print a box plot just to see the nature of my attributes. Okay, attributes means like this. B column is one attribute, C is one attribute, D is one attribute, E is one attribute. And my B must have some median, some maximum value, some minimum value, and so on. And that could be very nicely represented in a box plot. And in any machine learning algorithm, it's very much curious to see the nature of the data, what could be the maximum value, what could be the minimum value, what could be the median, and so on. So let's read it, then we can go for some other methods as well. So these are my files needed. Okay. Import pandas as PD, import numpy as np, import io, import matplotlib. This is for plotting purpose. And just because I have to import file from my hard disk, it's called import files, Google Colab. Okay. And at this point of time, I would again reiterate that pandas and numpy are very two famous packages in Python that have many inbuilt functionalities to handle data, to manipulate data, to carry out various kind of analytics on the data. And this import IO and Google Colab import files is meant for reading the file, reading the CSV file. So these 2 lines are for reading the CSV file. Files.upload is a keyword. Thereafter, we have to upload this iris file. So whatever the file name, we have to exactly given here, otherwise it will create problem. Okay. Now I want to load that file and I want to print my stuff. So this DataFrame is a feature from Pandas. By using DataFrame, I can retrieve all my data in the iris CSV file, but they all will be considered as text, even the numbers. That's why I want to make it a numpy array. So it will be eventually a 2-dimensional array. Okay. So 2numpy is a keyword. My data is not a keyword because my data is a data structure created by me. df2 is a data structure created by me. Uploaded is a data structure created by me. Clear? So the left hand stuff, all these 4 lines, look at the left hand stuff. The left hand names or the identifiers or the variables, we call it as it is, are created by me. But on the right side, we have keywords. Files.upload. pd.read underscore CSV. Read underscore CSV is a keyword. But pd is a alias. Alias means pd. So instead of writing pandas every time, I can write pd. Okay, so it's alias. Sometimes it happens like import x1.x, y1.z.p.q.x. Such is the directory. So in that case, we can give a name to that directory. Okay, so edge is a phrase to be used for that purpose. Okay. So renaming a big directory, we are using like import pandas hpd. So having this data, I want to print something. I can print my first column. I can print my second column. Okay. Why to print? Let's print everything. See, it asks my file, so I can choose my file from my directory. See, it's done, and it is showing me the data. You see, all the data are shown. Clear? So the first column is the serial numbers. The next 1, 2, 3, 4 are my features, and the last one is my labels, class labels. Okay. Now the idea is, if I want to plot a box plot only taking care of my columns, I have to delete my first column and the last column. First column is known as 0th column, and the last column is the 5th column, because there are total 6 now. 0, 1, 2, 3, 4, 5. So for that reason, I have to write this to sentence. I need not print anymore now. Okay. So there are 3 parameters. Look at that. Array is my numpy array, and 5th is my column I want to delete. Delete is an inbuilt function. NP is my alias for numpy. NumPy is renamed as NP. Delete is a function there in NumPy, so I should write np.delete. Array is the data I have. 5th is the column number. Access is 1, meant for I am deleting one column. If access could be 0, I have to delete one row. Okay. Now this final array consists of my data. It's nothing but like 150 row and 5 columns. And in my second line, final could be input, and I can delete my 0th row. So it will be having all my data intact, all my feature matrix 150 by 4. Clear? So in this, by this line, I remove 2 columns, first and last columns. Now I want to print the box plot. Okay, because of these 2 lines, these 2 lines uploaded and df2, I have been directed to read a file from my hard disk. So this file has been done 100%, and there are so many messages because of some reasons. We can avoid that later on, but for simplicity, I am not going through those lines why they are come up. But the box plot could be successfully printed. 4 attributes. Okay, and the orange line is the median of the data, and the bottom is my minimum of that attribute, and the up is the maximum of that attribute. And for all that attribute, you could see the distribution of the data. Okay, max of every attribute, mean of attribute, median of every attribute, and so on. This makes sense sometimes because you know the kind of diversity in data. But there are also other analytics called like you can reduce the dimension, you can plot them, and so on. Okay, but why I'm telling you this program? Because to convey a message, I have a purpose to tell this program just to convey that pandas and numpy are 2 data, two data processing packages much needed for machine learning algorithms, okay, in Python, so that I can remove my unnecessary columns or unnecessary rows, or we can separate my data and targets. Okay. Any doubts so far?
Yes, sir.
What do you mean by about data and targets, let me clarify. See, whenever these are the data, so this is my feature 1, feature 2, feature 3, and feature 4. And I want to have this as a separate array, and I call it my data, which has the dimension 150 by 4. And this is my target or expected labels. And the dimension is 150 by 1, because this is the class level. Okay. Now we'll go for next program. The next program is about training and testing a model. Okay. Training and testing a model. And before that, I'll tell you something, then we'll go to the programs. So as I told you, we are talking about classifiers, a very popular machine learning model approach. There are three things. I mean, initially we can call about training and testing. There are two phases. Okay. There is a model. We train. Okay, and we have some outcome. And based this outcome, we test. And we get the accuracy. Okay. So if I consider this 150 data, I can take that 70 for my training purpose and this for my testing purpose. This 30. Okay. So there will be 4 parts, And 4 parts, why? This is a part data, and this is a part target. This is a data for testing. This is a data for testing. This is the labels for testing. Okay. Let me check what is the stuff I'm using in my program. The notations accordingly I'll tell you. New data, new target. Okay. What I'm using for testing. IRIS data. Okay. So while training the model, I will give this 70 data, 70 rows, and the 70 row comes up 7 by 4 as my data and 7 by 1 as my labels. All must be clarified with this. Once I get the outcome, okay, now based on the model's information, model's outcome, I can test my data, and during the testing phase, I have to give this 30 by 4 as my test data, and this 30 by 1 as my test level. So while you do program, you have to think of this as a partition of 4 stuff. The data set is basically divided into 4 stuff. This is one approach. This is one approach. Okay. And if my test data is having 30 rows, then my confusion matrix if I'm talking about this iris data set only, then all these attributes summation is 30. And if it is 6, if it is 8, if it is 7, my accuracy is 21 by 30 into 100%. Clear? Because 8, 7, 15 plus 6 is 21. That's how we calculate. So this is the simplest way to train and test a model. Okay. But another approach is there that is called k-fold cross-validation. When you write paper for journals, you have to mention this, otherwise the reviewers will not be satisfied and will not accept your paper as well, and at all. If this way you present the data and you say that, okay, this is my final accuracy. If you claim this is my final accuracy, they will not believe you. They will say that you have not carried out k-fold cross-validation, so we are not accepting your paper. Please carry out your k-fold cross-validation. So for k-fold cross-validation, what happens? Let me tell you. So this k is an integer. And the data set is divided into k parts. Okay, K1, K2, K3, K4, and K5. That means my model is going to be trained K times. Okay, first my training will be K2 plus K3 plus K4 plus K5. With this data, I will train, okay, this part. And my testing data will be K1. Get a point? This is my testing, this is my training. And this process goes on. In my second case, my training data set will consist K1 partition, K2 partition, K3 partition, and K4. Sorry. My training in my second iteration could be what? K1 plus K3 plus K4 plus K5, and I can do my testing with K2. Okay. So the idea is that in the first run, I'll get some accuracy. I can call it accuracy 1. In my second run, I'll get some accuracy. I'll call accuracy 2. In third, I can have my accuracy 3. 4, I can have my accuracy 4. And the 5 run of my stuff, I have accuracy 5. So in every run, I'm generating a classification report and accuracy score. And finally, the overall performance will be accuracy 1 plus accuracy 2 up to accuracy 5 divided by 5. This is my average accuracy. We call it average accuracy. So that's how we report while doing some work in machine learning. Okay, the same thing we are going to implement now. Let's go back. I have typed the packages I need, the metrics, the NumPy, the data set that is iris, Now I can have the sklearn tree because I want to perform some kind of tree operation here. Okay, I want to have my decision tree classifier is not there. Okay, even if decision tree classifier is not there, it's not a big issue. Or we can write like that, decision tree classifier where I imported that like this. See something I'm mentioning here. Okay, look at this line. From sklearn.tree, import decision tree classifier and import sklearn.tree. Both are same, doing the job, same job, because sklearn tree must have many trees. Okay, and I want to only specifically use decision tree classifier, then I can write this line. Otherwise, I can skip this line. No issue. If this line is sufficient to make use of decision tree classifier. Okay. With this, let's move. Now, and I'm declaring one array called remaining, okay, to hold 30 data. So I randomly picked up. And keep on appending. Okay, initially this remaining array is null, nothing is there. Append means you keep on putting one more, and so on. So I'm putting the index randomly that is generated from 1 to 150 because this much rows I have. Okay. After that, I can take the data from those indices. Clear? So if I simply print also, no, I can simply print. Let's see. Let me tell you the thing. What is this remaining? I will tell you. See. So this array 98, 49, 7, 92 are nothing but part of my test data. So I'll go to 98 row and take the data and target. I'll go to 49th row, take the data and target, and so on. Clear? I hope you are clear by this. If at any point of time you are unable to follow, please interrupt and get the things clarified. See, my new target, that means my training. New target means my training data is I can delete all those data whose index is there in remaining. Okay. So this delete function can take the whole input, the targets, all inputs, and take the remaining. That means it will now have what? Even 120. 120. New target will have 120 by 1. Okay. Similarly, new data, see, I'm using axis 0 because I want to delete the rows. And here by default in this function, axis is 1. Even if I do not mention axis 1, it's there. Okay. So I can delete also, no issue. So this new data is 120 row and 4 columns. Okay. That is more my 4 features. I can train my model, and the model is there in CLF. Okay. Then I can store my predicted values somewhere. See, these are my predicted values. It is predicted with iris data, only the remainder. Okay. So what is this prediction is all about? It will only contain my 30 targets. Only 30 targets. This prediction will contain. Okay. I put hash here. Now I can print the confusion matrix and accuracy score. Let me tell you all these things. The confusion matrix will have how many things? The target, the original targets, and prediction. Get my point? So original targets, these iris target are the original targets of my testing data, and these are my predicted targets. Okay, these are original targets and predicted targets, and matrix original target and predicted target. What do you mean by that? Let me go back. Okay, I'm talking about this. So initially I have this is target. So this is my original target, 30 by 1. And the prediction array holds 30 by 1. This 30 compared, just like my very first program. Remember very first program, just like that, my prediction is going on and we could get the result. Check. There is some problem. Which line? Okay, I have committed some mistake somewhere. New target, 15 line. Okay, here no, here while showing you, I should have put the index. No, these are index given to the data though. It's showing error. Still the error. Let me check. No, new target not taking this reminder only. No, this is not the syntax. In fact, there is some problem. Let me check. So this is the syntax. Okay, got the result. There was some mistake. So the result is that confusion matrix we got for 3 classes. So very few data are meant for my, inability of my function, because 0, 0, 0, very nice, 0, 0, 1. So the accuracy is like 29 by 30. Okay, 29 by 30 is 0.97 to be precise. If we put like this, so 0.96666 and 7. So this is how we do. Okay. Any doubt?
No, sir.
Now I'll tell you this cross validation stuff. Okay. So for this cross validation, we have many things to be mentioned. Let's say the same classification model we are going to use. Okay, load iris is the data. This is centric classifier is the classifier. And just to, we have to have k-fold. So I'm using the syntax, stratified k-fold. If not, you can also manually subdivide the data into 5 parts and can make use of. So this print is not required. We have seen the data already. No need to print. And so folds is a keyword, and I want to fold into 3 parts, let's say. So it's a 3-fold cross validation. Now, average. I want to maintain one average array to calculate the accuracy for split 1, the accuracy for split 2, and the accuracy for split 3. Then finally I can get the result. I mean, find the average. Now there will be a for loop, I'll tell you. There is a for loop because the training index and testing index I have to put. Okay, so this training index and test index are not keywords, but false.split is a keyword which takes two data. What the data are all about: iris data and iris target. So it takes 2 inputs. What the inputs are? Size, it's like 150 by 4 and 150 by 1. These are the 2 inputs. Now xtrain, ytrain, xtest, ytest. These are the notations we'll be getting anywhere while searching code in GitHub or your friends or any tutorial. You should not be confused about this. Okay, I'll tell you what are they. So I'm dividing my data into parts like see. This is divided into 3 parts now. 3 parts. Now, I can subdivide it. At any point of time, let's say this is my training data, because I can only consider one partition as my testing data and the remaining partition is my training data. Okay, so 1 and 2 because it is 3 split. Now out of this, you see this is known as xtrain, this is known as ytrain. Means y is the target, x is the input for training data set. Remember, look at the algorithm. Okay, this is xtrain. Xtrain is my data and ytrain is my target. Okay. These two will be given to the model to fit the model. That means training purposes. This will be known as xtest, testing, and this will be known as ytest. Okay. So you should not be confused. What is what? Xtrain means the training data. Ytrain means the training levels. Xtest means testing data. Ytest means training levels. X is meant for data. Y is meant for levels or targets. Any doubt? Okay.
No, sir.
Okay, very good. So now training index and testing index are searched as for the folds because this folds really makes this training index and testing index as 1/3. Okay. I will also show you those training index and testing the data. That's why I'm differentiating them by putting a print in between, printing of dots. Then with the CLF classifier, see the fit model. Here I'm fitting the model CLF with xtrain and ytrain. My training data, my training target. Thereafter, what I do, I calculate the score and I want to print the score also. Let's not print it. If you want also you can print. Okay. and I want to average it, and append. Every time I append, because this loop will be running for thrice though. So this average will be calculated thrice. Then the average score will be calculated. So let's print the average, Yes. Okay. Now the thing is that I'm calculating the stuff. Finally, I can print the average score. I'll go out of my loop. Okay, in Python, we have to maintain with indent. In for everything is there. That means they includes that. I mean that is the part of the loop body. Okay? Average score is sum of the elements in my average array divided by the length of the average. Clear? So average accuracy you could get this way. Or you can also generate everything here. I mean, you can also check the confusion matrix for every time putting the loop. Okay, for that you can put like confusion matrix, accuracy score, and so on. But I'm not putting this just to make the output clear, but I'll show you also that. See what I'm getting. What is important to show you here is that initially, look at this. This is my training part, because the first first index I want to show is training index. So the training index means the 17th row, 18th row, 19th row, and so on is part of my training data. And at that point of time, 0th row, 1 row, 2nd row, and 115th row is my training data, testing data. Okay, and my accuracy is 0.98. Clear? And the second split, this is my training, this is my testing indices. And here in my second case, 0.92 is my result. Initially 0.98. In second instance of my model run, I'm getting the accuracy 0.92. In third instance, this is my indices of my training data. These are the indices of my testing data, and the accuracy I'm getting is 1 in third case. So the idea is, when I splitted my data set to carry out k-fold cross-validation, I'm getting 3 accuracies. First instance 0.98, second instance 0.92, third instance 1. Why? Because I appended in this average array. So here I appended after training. Okay, this append is nothing but the test score. So score means accuracy score. This accuracy score is calculated by putting test data in every instance. Okay. So this is the model for training, and this is testing. Okay. So the average is 0.98 plus 0.92 plus 1 divided by 3 is 0.97. Okay. So this is how we professionally report to the scientific community when we carry out a classification work over a data set we have at hand. Okay. So this is all about the basics of a classifier. In place of decision tree classifier, just like I show you, you can use MLP classifier, you can use support vector machine, you can use naive Bayes, you can use logistic regression, you can use MLP classifier. There are many classifier models there in scikit-learn. Okay, and Keras is a package where you'll get deep learning models like CNN, LSTM, long short-term memory, and so on. But due to constraint of time, I could not show you everything. But I planned what I will present should be concrete and you should know it thoroughly. Once you know some part of machine learning thoroughly, then it is not difficult for you to explore much more things and can do by your own. Okay. If the foundation is not strong, you will be very much confused. So this is all about the confusion metrics, the other assessment metrics for classification models, and how we carry out classification work in Python. Now, I hope 3:30 you have another class. Before that, I will also introduce you one more matrix that is called receiver operating characteristics, or that is called receiver operating characteristics curve, ROC curve, and it is very popular for binary classification. Okay. So in binary classification, I will show you something. You have only 2 by 2 matrix because this is a binary classification work. Okay. You have only 2 classes. One is called true positive, one is called false positive, one is called false negative, and true negative. So in this case, instead of going through all these performance measures, we do something like false positive rate and true positive rate. And we draw a curve. And the area under the curve is the performing parameter. How much your model is efficient, that will be decided by the area under this curve. And this curve is drawn by plotting the points for TPR and FPR. So if you have a k-fold cross-validation, you have k such points, and you can join that and you can have a curve and find the area under the curve. There is also the AUC score, area under the curve score, in scikit-learn. Okay, and this false positive is calculated by using this number FP, this FP plus FP plus TN. This is my false positive rate that forms the x-axis, and my true positive rate is this part, TP, true positive, TP plus false negatives. And this is true negatives, should not be confused. So this plus the whole stuff is called false positive. This divided by the whole stuff is called true positive rate. And this two stuff, whenever plotted against every run in a k-fold cross-validation setup, you can plot a receiving operator characteristics curve. And area under the curve is the main thing to keep track of, to know the performance of the model. Okay. With this, I conclude because I have to respect the time for the other speaker who must have joined at 3:30. But still, I beg your pardon, the organizers. I may take few minutes to reply the queries if the participants have any.
Participants, please ask your queries. We'll be happy to receive some questions from you.
Okay. If there is no question, can somebody acknowledge that whether the things could be followed easily, or I was a bit fast?
Please response, at least anyone.
Okay.
So there is a question that, sir, from where I should start machine learning?
I hope this is the starting point, the way I started. And as far as the books are concerned, you can go through one book called Machine Learning Algorithmic Perspectives by Stephen Marsaland, one book where he has explained the methods. I will write down the thing in the chat box itself. Machine learning, algorithmic perspectives by Marsland. It's a book to start with. And there are plenty materials also, or you can go to scikit-learn tutorial, Keras tutorial, or you can know that, PyTorch tutorial. The documentation is very, very user-friendly, very precise. So my second suggestion is that you can look at the documentation of either scikit-learn or PyTorch or Keras to get know about machine learning and advanced topics about machine learning. And the documentation you get from internet itself.
So she is asking another question. Sir, have you any machine learning course available in YouTube?
No, I do not have, but I know many experts who have been very great in their YouTube channels, and I'll share with the organizers, and the organizer can pass it to the participants later on.
Yes, sir. Anyone? Either they have understood everything, or maybe they are just using their mobile for just attending the session. So I think there are no questions from the participants.
Okay, Atishi joined PhD with you.
Yeah.
It seems like Alok.
Yes, sir.
Yeah,
In
yeah,
ICT doctoral fellowship.
Okay, that's great. Yeah.
Yes, sir.
और Atishi कैसे हैं आप? ठीक है? Atishi ठीक है आप?
Yes, sir. How are you?
I'm fine. Okay, all the best, Atishi, for your new journey. Okay, participants, any more question?
Sir, one question.
Yeah.
Sir, in model.fit, if the number of columns are different, will it be going to fit? Means the number of rows are same, but the number of columns are not same.
No, it will not be, because for every corresponding row, I have to have a corresponding target. So certainly, it's not possible.
Okay.
Any more questions? Okay, then all the best, participants. Hope the things we discussed will be helpful for you in your future works. And with this, I also thank organizers and our dear friend and ex-student Alok. Alok had been a student in NERIST as well. So we are the alumni from the same institution. And with this, if Jayantaji is there, I also convey my regards to Jayantaji. And my deepest regards to Sanivar sir also. He must be there, I think so.
He's maybe in a meeting.
Oh, he's in a meeting here.
Thank you very much, sir.
Thank you so much. Thank you. See you
Yeah,
there. See you, Alok. Take care. Take care.
So let's